NASA's Webb shocking new discovery before the Big Bang. Unbelievable is the Webb Telescope. The universe, though, is far more than that, right? Although this new technology is limited in what it can accomplish, it is already revealing amazing things by recording some of the earliest light produced after the Big Bang. People have begun to wonder, does Webb allow us to glimpse the entire universe? After the magnificent first photographs from NASA's James Webb Space Telescope were released. So, why can't it see everything there is or ever was if this incredible new telescope can see into the darkest corners of the universe, almost to the beginning of time? Astronomer Garth Illingworth works for the University of California, Santa Cruz. He was a crucial figure in the conception of the Webb telescope in the late 1980s, is an expert on the instrument, and patiently and swiftly responds to even my most inane inquiries. What we can see sits within a massive ball, but it is not the entirety of the universe, Illingworth said. We can only view the part of the cosmos that is within the light travel time from us for the age of the universe. The cosmos might be limitless, yet it is still much larger than anything we have ever seen. Hard to get one's head around this, I agree, he concluded in kind. For a minute, let's ignore the universe's staggering immensity and potential infiniteness. The astronomy of Webb's successful launch deployment and initial scientific results are significant. However, be clear that not all the universe's mysteries are able to be revealed. We humans carry a very extensive and intimidating list of things we don't know. The new telescope can make some progress toward unraveling them, but the majority of the mysteries will need to be solved by upcoming scientific tools. And today's third graders, who will be scientists in the future, ask their parents simple but excellent questions like, does life exist outside of Earth? Does extraterrestrial civilizations exist? What is the underlying makeup of the energy and matter? Why does gravity exist? What will happen to the universe, and why is it expanding? The most important query is, why does anything exist as opposed to nothing? The Webb telescope, which orbits the Sun at a distance of around 1 million miles from Earth and outperforms expectations, was built with a specific set of unknowns in mind and wasn't suited for addressing all the other non-knowns. The telescope was initially envisioned by scientists as a device to try to capture some of the first light of the universe, which was released not long after the Big Bang, when awkward little galaxies were just beginning to form and had not yet grown into magnificent spirals like Andromeda or our own Milky Way. The redshift of such far-off objects is how far the expansion of space since the Big Bang has pushed their light wavelengths toward the red end of the spectrum. The galaxy is farther away in both space and time the higher the redshift. Although there have been prior infrared observatories, the Webb has a significant larger mirror. The Spitzer Space Telescope examined that area, and even the Hubble observed a little amount of infrared light. The telescope that could observe those very early galaxies in such detail has never existed. Planetary astronomer Heidi Hamel wrote in an email, "It is like humanity just obtained a brand new pair of eyeglasses for the far universe." She has a talent for breaking things down so that regular people like us can grasp them, just like Illingworth. We are suddenly noticing that these green regions at the tops of trees are formed of thousands of individual leaves, she wrote in her email. Although we suspected it, we are just now becoming aware of it. Light is a remarkable achieving aspect of the universe. With a maximum speed of 186,000 miles per second, it moves. It continues to travel across space until it comes across something, such as a dust particle or a telescope's mirror. Because everything we observe is a snapshot of a particular moment in time, astronomy can be thought of as a type of cosmic archaeology. A light year, or 6 trillion miles, is a unit of measurement for distance. We therefore observe the light that an object that is 4 light years away gave off 4 years ago. The closest big galaxy, Andromeda, is a few million light years away. Over 13 billion years ago, the first galaxies began to shine. Project scientist Jan Rigby famously remarked during a news briefing on July 12 at NASA's Goddard Space Flight Center, "The universe, it's been out there. We just had to construct a telescope to go see what was there." A telescope that can function in extremely cold temperatures is necessary to see that weak infrared light. Storing it far from our Earth's source of warmth is required. It also entails constructing a sizable mirror that will act as a light bucket. 18 gold-plated hexagonal mirrors that can be moved separately and work as a single 21-foot wide mirror were the engineers' new and hazardous design. The telescope had to be folded when launched in the rocket's nose cone due to the size of the mirror. It had to unfold in a succession of delicate deployments while hurtling across space, much like a flower blooming. That involved the unfolding of a tennis court-sized, 5-layer, ultra-thin sun cover. The European and Canadian space agencies, along with NASA, bet that everything would go off without a hitch. There wasn't much room for error. If something became jammed, the engineers could order the telescope to sway and tremble, but it was a rudimentary emergency solution. The Webb was alone in space, too far away for astronauts to repair it, and lacked interchangeable modular components like the Hubble's instruments had. The researchers were anxious. Engineers were uneasy. The NASA executives were anxious. This reporter is one of those who believed that this telescope had a very good chance of ending up at a $10 billion paperweight. On July 12th, NASA scientist John Mather, who received a Nobel Prize in Physics for his study of early cosmos, said to the crowd, "It is impossible to describe how difficult it was. However, it was successful, and now the focus is on incredible science rather than amazing engineering. I was kindly guided through the capabilities and limitations of the Webb by Jane Rigby. One thing I discovered was the Webb isn't completely in the dark, even a million miles from Earth, because of the sun shield, which offers the equivalent of SPF 1 million. The sun's reflection of dust causes the skies to glow in the infrared region of the spectrum." Rigby remarked, "It's our silly solar system, the zodiacal cloud, I believe, that illumination comes from our solar system. We are unable to escape our solar system because we are trapped there. Unless they're kind enough to blow up for us," she continued, "the Webb probably won't be able to view the very first stars." However, Webb has already found a galaxy that only began to emit light 300 million years after the Big Bang, which is undoubtedly a record. To determine what elements are present in that light, the telescope's instruments can perform spectroscopy on it. How are we created? Rigby poses a pretty straightforward inquiry before elaborating on her meaning. How are oxygen, carbon, nitrogen, and iron made? How is the periodic table created? I believe Webb will provide some significant scientific research in that area. Examining exoplanets or planets that orbit far-off stars will be one of Webb's most fascinating duties. One intriguing candidate is TRAPPIST-1, a red dwarf star orbited by 7 planets, some of which are thought to be in the habitable zone, where liquid water may exist on the planet's surface. Webb can't directly observe these planets, but they can tell if they have atmospheres by observing how they affect the light from the stars they circle. The scientists are trying to determine if planets can maintain their atmospheres despite the severe radiation storms that red dwarf stars occasionally release. Webb should respond to that and maybe find carbon dioxide, methane, and water vapor in the atmosphere. Although it would improve the existence of life, it would improve our knowledge of exoplanets. Future telescopes might be able to view surfaces as well as atmospheres, including ocean glint, according to NASA Goddard astrophysicist Nicole Cullen. Over the past half-century, science has generally been so successful that it has raised the bar for new researchers, notably in physics. What will be Webb's most important finding? Its most valuable aspect might simply be its effective use as a tool that generates enormous amounts of scientific work. Let's just keep in mind that we're working on the huge unknown for the time being, rather than trying to predict the future of gravity, cosmic destiny, or life on other planets. A snazzy new telescope won't be able to feed the hungry, advance justice, put an end to war, or mitigate the worst consequences of climate change. So technology almost certainly won't be able to address every one of our world's problems. But when something like Webb comes along, it serves as a reminder that we are still capable of doing the difficult tasks. That's it for now. I hope you guys enjoyed watching it, and if you did, be sure to leave a like and subscribe for more. And I'll see you guys in next time.